Okay, this lesson is going to be a recap of everything you learned about lines and slope, okay, and then also relating that a little bit to some average rate of change and to some secant lines. So let's go back all the way to the beginning, way back when you guys learned about horizontal and vertical lines. Maybe you remember something called Vox Hoy. Okay, so what Vox Hoy helped us to remember, H-O-Y. H stands for horizontal. Okay, so a horizontal line looks like a horizon, looks just like this. Okay, the 0, or the O, was supposed to help us remember that the slope is 0. Okay, and then the Y, okay, the equation of a horizontal line, the equation is going to be Y equals. Okay, so for example, this horizontal line right here has a slope of 0. The equation of this line is y is equal to 1, 2, 3. Y equals 3. The reason for that is all the y values. This point right here is 1, 3. This point right here is negative 3, 3. All of the y numbers are 3. Okay, and if you think about a guy skiing, okay, skiing, going downhill skiing, yay, on a line like this, okay, the slope is 0. Okay, you don't really go very fast when you're just standing on horizontal ground. Okay, now how about Vux? Vux, remember that? V-U-X. Okay, V stands for vertical. A vertical line looks like this going up and down. Okay, if you think about a guy trying to ski on a line like this, oh my goodness, oh, he is not going to be happy. Oh, okay, you cannot ski like this. The slope is undefined, and that's what you say. The slope is undefined, okay? And then the x was supposed to help us remember that the equation of a line like this is going to be x equals number, okay? So the slope of this guy is undefined. His equation is x equals 1, 2, x equals 2. All of the points have x values of 2 right there. Okay, and then things get a lot more interesting when you get on this side of the chart. Okay, everything over here, okay, is probably what you remember doing a lot more of, these uphill and downhill lines. Okay, think about a car. From left to right, when it drives, this car, okay, is definitely going uphill. The slope here, okay, the slope is positive. The slope is positive. Car going like this, going downhill, okay, the slope is negative, going downhill, okay. Now, what about the equation? Is he going to have an x or a y? Okay, and the answer for diagonal lines is both. Y equals mx plus b, okay, where the m is the slope, and then the b value, that's the y-intercept. That's where it crosses the y-axis.
Deal a lot with the
If I look at this equation right here, his y-intercept is at 1. Okay, and so is this one, positive 1. Where does it touch the y-axis? Let's go remind yourself of average rate of change or slope. Okay, so for both of these, there's a couple things. Maybe you guys remember delta y over delta x. Maybe you remember it being called rise over run. Rise over run. Okay, when you're looking at a graph, between point to point you rise up, then you run over to the right, rise over run. This would be the delta y, and then this would be the delta x. Okay, the formula is y2 minus y1 over x is delta x. What's the change in x? x2 minus x1. Okay. Now, does it have to be y's on top? Absolutely, yes, you have to have the y's on the top, okay? But what about if I did y1 minus y2? Am I allowed to do that? Yes, but if you start with y1, you have to start with x1 to keep things fair. okay? But you have to put the y's up, okay? You gotta wise up, right, people? You gotta wise up. Put your y's on the top. And you have to be smart. Okay, how do you do this? Okay, so the steps to doing this, the steps are number 1, find 2 points. A lot of times they'll give you 2 points, but you might have to find 2 of them. And then step 2, calculate the average rate of change, okay, or you could call it the slope. All right, I'm going to show you why there's 2 names here in just a second. Okay, so if I have 2 points, let's find the slope between these points. So this first point I'm going to call x1, y1. That's the first point. And this point is going to be x number 2, and that's y number 2. Okay, so to do the slope, let's use m and equals for the right letter. Okay, and now you have to decide which one is going to be your starting point. Okay, I'm going to use this point right here. I'm going to start with that point. Okay, so I'm going to do y, 5 minus. Then the other y, 5 minus 2. Okay. Now let's go to x's. We've got negative 3 minus the other x, which is negative 1. And what happens when you have a minus minus? That's right, it turns into a positive. So the slope is 3 over negative 2. Okay, now we're not going to keep the negative in the bottom like that. You never keep your negatives in the denominators, okay? So here's how you're going to do it. You're going to put the negative up on top for everybody to see, okay? Or you could put the negative out in front of the fraction, negative 3 halves, for everybody to see, okay? But do not keep negatives in the denominator. Let's just put a note, okay? Do not keep negatives in the denominator. It's just not where we keep them, and they're hard to see. Okay, so if you have 2 points, you can calculate the slope that's between them. Okay, and a lot of times, slope is for a line. Okay, so slope is for straight lines. But what if we have a shape that's more like this parabola here? Can I figure out what's the average rate of change from point to point? How does it change? Okay, now it's not a line. This graph goes down, 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 and then it goes up, 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 but I can still calculate the change from one point to the next. All right, and here's where those steps are going to come in handy. Step 1, we have to find 2 points. We have to find 2 points. Okay, so what do we have? We have an equation going from negative 1 to 3. So the first thing I'm going to do is do f of negative 1. I'm going to plug negative 1 into this equation. 3 times negative 1 squared minus 4. Okay, and what does that give us? That gives us negative 1, right? Okay, so I just figured out when you plug in negative 1, we get a y value of negative 1. That is our first point. All right, let's do it again, okay, because it says from negative 1 to 3. So now I have to plug in 3. All right, so I just figured out this was the point, negative 1, negative 1. Now I'm trying to figure out 3 comma what? What's the point over here? So let's plug in a 3. We've got 3, input a 3 squared minus 4, and what does that give us? (27) minus 4 gives us 23. Okay, so I just found the second point to be 3 comma 23. All right, so step 1, find 2 points. Check. Step 2, find the average rate of change, or in other words, the slope. Okay, so average rate of change is for equations higher than linear. If you had a parabola or a cubic or a quartic, anything higher, you could figure out the change between the 2 points. It's just that we don't call it slope, okay? But we do have our 2 points, and now let's do the slope, okay? Y minus y. I'm going to start with the big number, 23 minus negative 1. Change in x, x minus x. A minus and a minus make a positive. And so we have 24 divided by 4, which makes a slope of 6. Okay, all right, let's keep going. Hopefully everything we do here today is something you remember. If you need extra help or you're rusty, then please come get some help on it. The second thing is point slope formula, which is the one that I don't think most people learned when they first started, but it's actually the easier formula to know. Okay, so here it goes. To do point slope, first of all, you need a point, okay, like an x comma y. All right, and then you also need a slope, and the slope is going to be an m. All right, here's the equation. Y minus, okay, and then you put the y number, equals, okay, m times the quantity x minus x1. All right, and remember m is the slope, and then there's your point. Okay, so your point and your slope. Let's look at an example. Okay, now that you're older, most people say that this is actually a lot easier for them. Makes it just a little bit easier of calculations. It's not the one that you learned first, so people don't tend to do it, but let's try it, okay? Write the equation of the line in point slope form. Okay, so we'll keep it like that. Here's the point, here's the slope. Okay, so y minus, give me the y number, 2, equals, do we have the slope? 4. And then x minus, the x value is 1. Okay, and that's it, we're done. That is point slope form. Point slope form. Now if you go to graph something like this, it's a little different. The point, 1 to the right, 2 up is right there. There's the point. And then the slope, if we go up 4, 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. Okay, so here's the line that they're talking about with a slope of 4 going through the point 1 comma 2. Okay, most people are used to seeing this in y equals mx plus b form at the y-intercept, but there's also this other version. Write the equation line in point slope form. Okay, good to know, point slope form. And here's 2 points. Okay, wait a minute, point slope form. To do point slope, I need to know the slope. Okay, and they didn't tell it to me, so what are we supposed to do? We're gonna find it ourselves, right? So let's do a little calculation for slope. Y minus y. I'm going to start with this 7 minus 4, and then x is 2 minus minus 4. That gives us 3 over 6, which reduces to 1/2. Okay, now we have the slope. Okay, and we've got 2 points. We've got 2 points, okay? Your choice as to what point you want to use. Okay, maybe I will use this point right here. Okay, so y minus, give me a y, 7 equals m, which is 1/2, times x minus 2. Okay. Now, is that the only option? No. Okay, you can use the other point. So for the answer key on a test, this is a great answer. Okay, or for people that chose the other point, I would have to accept that answer as well. Okay, so if you chose this point, y minus 4, you're going to both have the same slope. Okay, that's not going to change. The other x value is x minus a minus, which is a positive 4. Okay, so there are 2 different answers here depending on the point that you choose. Well, let's keep going. Slope-intercept. Okay, so this is the one most people remember. Okay, slope is m, and intercept, intercept is the y-intercept, which is the letter b. Okay, y equals mx plus b. All right, so let's find the m and the b and let's graph it. But you can't do it when it's like this. It has to be written in the correct form. Right, so the first thing I notice is the x value, you have to get moved to the other side. Okay, and when you switch sides, you switch signs. So now the 2x is negative. Okay, it's still not y equals yet. I have to divide everybody by a 4. All right, so let's see. Y equals, let's reduce this fraction, negative 1/2 x plus 2. Okay, now I've rearranged it into slope-intercept form. What's nice about this is you can tell me the slope and the y-intercept. So the slope is negative 1/2. Okay, so which way is this line going to be going if the slope is negative? Okay, so this equation is going to be going downhill. And the b value, the y-intercept, is 2. Okay, the y-intercept. So when you go to graph, let's just put a note here. Okay, start the graph with the y-intercept. So here's the y-axis. My y-intercept is 2. Okay, some people like to say, instead of b equals 2, they like to say 0, 2. There's the y number, right? The y-intercept. And now it's time to use the slope. Okay, the slope is negative 1/2. Down 1, 2 to the right. Rise, up and down, and then you run. Down 1/2. Okay. The other way would be up 1, left 2. Up 1, left 2. Okay, and then you get out your ruler, and this line is definitely looking downhill. Okay, I want you to draw as many points as you can fit on the graph paper. Okay, so fill up the graph paper, okay, with as many points as you can. With as many points as possible. Not just 2 points, okay, but finish the graph. All right, can you write an equation? Sure. Let's write an equation. The slope is 3, and the point is negative 2, 3. Okay, so when I'm seeing something like this, I'm thinking I'm going to do point slope. I see a point in the slope. Y minus the y number equals m. X minus the x number. Okay, but wait a minute. The direction said in slope-intercept form. Okay, so I know that that's what the direction said, but I liked this since I had the point and the slope. Now all I'm going to do, okay, is rearrange. Rearrange. Let's distribute the 3. Y minus 3 equals 3x plus 6. Okay, and then I'll add 3 to both sides. Add the 3, and now it's in slope-intercept form. Okay, slope-intercept form. So sometimes starting with point slope is easier, and then just distributing. Okay, now some people say, well, hang on, isn't there a different way? Because when I learned this, back in grade school, we did y equals mx plus b. You can certainly do that. Okay, so let's use this y number. We'll use the m number. Then we'll use the x number. Okay, and we'll calculate the b. We'll find the b value. So 3 equals negative 6 plus b. Add the 6. Oh, now I have the b number. Okay, and then once you find it, then you have to replace it back in. So remember, point slope form, we still have to write the equation. Y equals, give me an m, 3 times x plus 9. Okay, so you can do it this way. There's lots of ways to do algebra. If you have fractions and then you're adding and subtracting fractions, sometimes this way does get a little more complicated than the other way. So try the point slope and let me know what you think. Okay, write the equation in slope-intercept form if you have 2 points. Okay, so how do you do slope-intercept form if you have 2 points? I don't even see a slope. Well, we're going to have to find it ourselves, right? Let's find the slope. Please tell me what you get for slope. All right, let's see if you got it. Y minus y over x minus x. 14 divided by 2. I hope you got 7. Okay? Now, it says find the slope-intercept form. Slope-intercept is y equals mx plus b. Okay? But I'm going to do point-slope form. I'm going to do y minus. Now, I have to pick a point. Maybe I'll pick this one. It's got a little bit less negatives. Y minus y equals m times x minus 1 is plus 1. Okay, but I can't leave it in point slope form. I'm going to have to rearrange. So the first thing would be to distribute the 7. And then I have to add the 8 to both sides. Okay, no matter what point you chose or what method you chose, everyone's going to have the same exact answer in slope-intercept form. Okay, so to just make note right here, this is point slope. This is point slope, and then this answer right here is in slope-intercept. Okay, we've got one more page here. Okay, and this is a secant line. Okay, so a secant line, maybe you remember this from geometry. Okay, a secant is a line, of course it's a line, okay, that intersects, twice. It intersects twice, okay. Maybe you guys remember that a tangent line intersects in one point, okay. So if I have a graph that kind of looks something like this, okay, and then I take a look at a line right here that goes like this. It's a line that intersects the graph in 2 places. Okay, so it's just another fancy way of saying, can you do a line? Okay, so this might be the point A, comma, what would this be called? The y value that goes with A. We're going to call this f of A. And then this point here I'm going to call B, comma, what would this be? F of B. Okay, so we've got 2 points. How do you find the equation of the secant line? Okay, very simple. Step 1, you find 2 points. Just like we did in the last couple examples. You find 2 points. Step 2, calculate the average rate of change. Okay, remember, I can't call it something else because it's curvy, but when I say average rate of change, you say slope. Okay, and then finally, write the equation. Write the equation, okay, of the secant line, the line going through 2 points. Right, and there's 2 ways that you could do the secant line. Remember, you could do point slope. Y minus y1 equals m times x minus x1, or you could do y equals mx plus b, okay, depending on the directions or the information given. Okay, so here's an equation, it's a parabola. Find the average rate of change from -2 to 1. Okay, remember how to do this? First thing I'm going to do is plug in -2. So 3 times -2 squared minus 2 times -2 plus 3. Okay, so what does that make? Okay, so that makes 19. So I now have the point -2, comma 19. All right, let's do it again. Let's do g of 1. So 3 times 1 squared minus 2 times 1 plus 3. What does that make? I hope you're trying to do this in your mind, right? 3 minus 2 plus 3, that's going to make a 4. So now I have the point 1, comma 4. Okay, step 1, find 2 points. I got them. Find the average rate of change. Well, that's just the slope. Okay, so the slope is 19 minus 4, -2 minus 1, so that's going to be 15 over -3, -5. Got it. Find the equation of the secant line. Okay. the secant line in slope-intercept form. Okay, from -2 comma g of -2, 1 comma g of 1. What does this mean? What does this mean? G of -2? Okay, well guys, they couldn't tell you. They couldn't tell you the y value because they wanted you to find it yourself. G of -2 is actually 19. You found that when you did the work. They couldn't tell you the answer. So I know this is -2 comma 19. And then 1. And g of 1 makes a 4. Okay, so find the equation of the line between these points. Okay, I'm going to do point slope. Y minus, which point would you like to use? I like to use the one without the negatives, right? Y minus y equals m x minus x. But it did say slope-intercept form. So we have to rearrange this, right? So please distribute the -5 and add the 4. And then what does that make? -5x plus 9. Okay, now how do we check this with our calculator? Okay, we could graph g of x and the secant line. Okay, so we can go ahead and graph both of these. I'm going to get my graphing calculator just to check to see if everything worked. Okay, so in y equals, clear out anything from before. Your g of x is 3x squared. Make sure you get down. Minus 2x plus 3. Y number 2. Okay. The secant line that I'm checking is -5x plus 9. So is this really the line going through the parabola in the right places? Let's see. I'm going to zoom standard number 6. That gives me a regular piece of graph paper. I don't like how I can't see up here. I really want to go higher on the y-axis, not as low on the y-axis. So if you hit window for the y-axis, let's go up to 20. Maybe I'll only go down to -5. Okay, does that allow me to see things a little bit better? Okay, so the g of x, the parabola, okay, looks like this. This is the parabola. And then the equation of the secant line that we figured out, okay, is going like this. Now the question is, what are these points? What are these points? Okay, and I'm going to go ahead and do intersection. I'm going to do intersection to see what point that is. Okay, so second, calculate intersection. Y1, parabola, enter. Y2, enter. Okay, now I'm going to go over here and see what this point is. And that's the point, -2 comma 19, okay, which is exactly one of the points that we said it was going to be. Okay, and is this other point over here 1 comma 4? Let's go see. Calculate intersect 1, 2, and instead of like arrow, 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 okay, you could type a number. I want to see if it's 1 comma 4. So I'm going to type x value of 1, and it does take me 1 comma 4. Can you determine the equation and the slope of horizontal vertical lines? Can you state the slope formula for 2 points, or in other words, the average rate of change? Can you write the equation in both point slope form and slope intercept form? I hope so. Okay. Can you find the equation of a secant line, which is really just a line with some fancy words? Good job, guys.